compute explicitly the given quantity where possible. If A is 5 factorial, 3 factorial, 0 factorial. This, remember that you have solved this question in varieties. 0 factorial is just 1. And these will cancel, so we'll get 20. So that since we solved B, we can go to C. 4, 5 choose 3. The first thing we do here is we first plot out 5, 3, so that we know what kind of a number it is. That's 5 factorial, 3 factorial, 5 minus 3 is 2 factorial. So we have 5 by 4 by 3 factorial over 3 factorial by 2. So this drops to 10. So what we are having actually is 12 to 10. When you reach here, and your sisters are not following you up, you can easily get that one. D, -2, choose 3. By definition, this is -2 factorial over, hello?
Sorry for disturbing. Is B a factorial or?
Is B a factorial or B is 12 to 7? Calculated in the same way I'm calculating this one. That's how you find B. Then you come and find this one.
Okay, thank you, thank you.
There was a gentleman calling for attention there.
No.
Okay.
Yes, it was the same question. I thought it would end there.
No. Okay. Then -2 choose 3. That is -2 factorial. Remember, -2 factorial divided by 3 factorial minus 2 minus 3 factorial. This means that from top there, we have -2, -2 minus 1, -2 minus 2, -2 minus 3, divided by 3 by 2 by 1 by -2 minus 3 factorial, so that this and this guy can cancel each other. Then you remain with -2, with -3, with -4 over 3 by 2, giving us and the response remains -4 as a factorial. Unless otherwise, this is enough to say that we've answered the whole question 1, because 0 chooses 0. It is just a Let me answer F. 0 choose 2. Hello?
What if I use that binomial theorem of n open n minus 1 cross n minus 2 cross over 3 factorial?
N open n minus
1 cross.
Is it network here or
n minus 2 over 3 factorial? Over 3 factorial.
Which is what we have used here, is it?
Okay, sir.
All right. There is too much of theorems. Right.
So I wanted to find out. Here on D, we have got -2, which is smaller than the choose 3. So how is that possible? Or is that on when you are doing factorials can apply, but in other theorems can't?
Let's see if what you're saying works here. 2 factorial, 0 minus 2 factorial. They're giving us 0. Now look, and this is 1 over 2 factorial, negative 2 factorial. So the new issues, the reason why what you're saying works for F and not for D is because this guy here, its factorial does not terminate. If you try to simplify and get the actual value, you get 2 times 1, which is just 2. Then you start -2 minus 1, -2 minus 2, -2 minus 3. You keep going. When you're tired, negative. When you're tired, someone will come and add. Let's say you end at n at -2 minus 100. Someone will come and say, you don't end here, come here, -2 minus 1000. So it keeps going. This is the more reason why we say if they are positive numbers, it must be 0 less or equal to r, and this r must be less or equal to n because they are positive numbers. So that theorem does not include the negative ones. It excludes them. It only gives a condition that if this is a situation, you require that the factorials be in the form nr for you to be able to use them. So that at this point, if you had forgotten all the theorems, you could go as far as here and then end there and say, hence, this is how far this thing can go. Since the n is less than r. Okay. Question 2.
Sir, before we proceed, on C, how did you find 10 so that it can be easy to find E as well?
How did we find 10? So earlier on we defined n choose r to be n factorial, r factorial, n minus r factorial. What we have inside C there is a 5 choose 3. So you work it out as 5 factorial, 3 factorial, 5 minus 2 minus 3.
We ignored 4.
No, we haven't ignored it. So we'll get 5 by 4 by 3 factorial over 3 factorial by 2, giving us a 10. This is just 5 choose 3. Where there is 5 choose 3, we'll put 10 and bring back the 12 in its original position.
Oh.
All right. Okay.
Also, 0 choose 0, it's 1, right?
0 choose
0, it's 1.
The problem is that you overthink. 0 choose 0. This is the same as n choose n. Giving us what? N factorial, n factorial, n minus n factorial. So obviously it will be n factorial over n factorial, which is 1. Just telling us that any number choose itself is 1.
Okay.
Kofunda sako nikukagwirirako.
Question 2. The coefficient of x3 in the expansion of 3 plus bx to the power 5 is negative 720. So the coefficient of x3 is negative 720. Find the value of the constant b. Now, where do you find x3? If you were to expand, you would say 5 to 0, 3 by 5, plus 5 choose 1, 3 by 4, bx power 1, plus 5 choose 2, 3 choose 3, bx squared, plus 5 choose 3, 3 squared, bx power 3. We have found the x in x, the term in x3. So we are told that this whole thing, 5, 3 squared, b power 3, x power 3 is supposed to be the same as negative 720 x3, since they are saying negative 720 is the coefficient of x3. So that the x3s now can wait somewhere as we deal with 5. Now 5 choose 3, we have found it here. It is 10. So we have 10 multiplied by 9 by b power 3, giving us negative 720. So this is 90. B3 is equal to negative 720. Divide by 90. Divide by 90. B power 3 is equal to negative 8. So that the cube root of these guys, the cube root of this is going to be negative 2. It serves as a value of b. If question 2 has been solved, then we'll do nothing on question 4 and 5. So we're on question 3. Show that n choose 0 plus n choose 1 all the way up to n choose n is the same as 2 power n. Now, the binomial theorem says that a plus b to the power n is the same as n choose 0, an, n choose 1, an minus 1b, n choose 2, an minus 2b squared, until you have n choose n, bn. So in questions like these, just have to be wise in making the choice of A and B so that you get 2. And then the A's, B, A do not affect those coefficients there. Because as you can see in our proof, there is this, there is this, there is this. All the terms are there. So all we need is to say, let A be equal to 1, B be equal to 1, and deal with 1 plus 1 to the power n. This will give us n choose 0, 1 power n, n choose 1, 1 power n minus 1, 1. Now it's not nice writing 1 to n power because you know 1 to n power, even the power you don't know, is 1. And 1 multiplied by anything is that thing, even if you don't know what it is. So you really to just be n choose 2, and you keep going until you reach n choose n. But who doesn't know that 1 plus 1 is 2? and this is the situation. That's how easy some questions can be if you understand what the general theorems mean. So that at your own free time, you are able to think and do B. This was A. So for B, I can give you a guidance. You make the choice of A to be 1 and B to be -1. Then substitute throughout in the expansion. And then take the negative numbers the other side. In fact, they are combined. So just substitute and for whatever you get. Question 4 is that question 4 and 5 have been answered in 2. I can just make a comment on question 4b. Since it looks like it's a product of 1 minus 5y multiplied by a mean of 1 minus 4y multiplied by 1 minus 5y to the power 8. And they want how many terms? First 3. So expand this one up to the first 3 terms. Then multiply the expansion by this. There's nothing to expand on the first one because it is power 1. And you don't expand power 1. You expand it to where? Nowhere. So you expand this piece up to 3 terms. Then you multiply your expansion of those 3 terms by this. So that next week we'll start from question 6. We'll finish this tutorial sheet next week and start tutorial sheet. This is 6 and start tutorial sheet 7. Don't miss. If you miss, you will meet in the recording in the group. Have a good day and lovely weekend.
Sir,
Hello.
Sir,
now question 2, there is that stuff of saying a to the power n minus r. It cannot be used there.
Those stuffs. the stuffs can only be used by those who understand them.
Yes, I have liked this method of yours. I'll be applying it.
Good.
Sir,
Yes,
our test papers, did you mark them?
they are marked and I think she's even done entering. Any time from now, the CA may pop up on Moodle.
Okay, sir.
Mhm.
so how was it, sir?
Mm.
Sir,
No, I think
So
that's-
some of us some of us on our partial CS, we didn't see our results.